Okay, well, let us really do A. So the partial derivative with respect to x so as you know, if we are assuming this one as u, so it is going to be e raised to u, that means x squared plus y squared times the derivative of the exponential function because of chain rule. That is what we have to really focus on. And then when we do this, this end up being actually e the power of x squared plus y squared is as kept as it is. This y squared is really constant, so the derivative is going to be 2x. So if you want to write it in compact form, 2x e raised to x squared plus y squared. That is the partial derivative of this function with respect to x. And then the partial derivative of this function with respect to y will be the same thing. We are differentiating this time with respect to y of the function e raised to x squared plus y squared. And that is using chain rule. The derivative of natural base exponential function is the function itself times d of dy of x squared plus 2y. I'm sorry, y squared. I'm getting ahead of myself. Okay, this will be e the power of x squared plus y squared times 2y That's it. We're done. Now do the same thing for B. Tan inverse. I want you to do this one because it is involved with rational function, and I want to make sure that you simplify it and make it compact. Because we are going to deal with this kind. By the way, is this clear, guys, what we have done? Come on, guys, answer me.
Yeah.
All right, let's do this. Okay, the partial derivative with respect to x of xy and as you know, this is going to be arctangent is 1 over the argument 1 plus the argument squared 1 plus y over x squared times d of dx of the argument. That means 1 plus y over x. All right. As you know, this one, I will come back and simplify this one. Or why not I do it now? This is 1 plus 1 and plus 2y over x plus y squared over x squared. And that is what I have when I expand this one, and multiplied by the derivative of this function with respect to x. The derivative of 1 is 0, and this is going to be simply negative y over x squared. Is it clear how I come up with this? Yes or no? Okay. Then now, what we are going to do is, let us really make it compact. This is 2, and the least common denominator is going to be x. So I'm going to write it 1 over 2x squared and plus 2xy plus y squared over x squared times negative y over x squared. And as you see, this y squared will cancel this one, because over means you are taking it reverse way. So this is going to be negative of y over 2x squared plus 2xy plus y squared. And we're done. Well, then if I walk you this one step by step, why not you do the partial derivative with respect to y of xy and give me the answer. Yeah, seemingly very simple functions, but I want you really deal with the algebraic manipulation. That is why I gave you this. One, you remember derivative rules. Second, really, can you handle the algebraic manipulation? Especially rational function will throw us off a little bit, and that is why I gave you. This won't change. What changes here? Well, as you know, the derivative of this one is simply 1 over x. Is it clear, guys? Because this is 0 and 1 over x is the coefficient. The derivative of y is 1. And that's why we get this. So again, when you simplify, so this x squared at least will be cancelled by 1x and it will come to the numerator. And we're done. Okay, shall we move on and do another example? For example, the geometric interpretation, or you had enough? All right, so let us do the geometrical interpretation. And here it is. Find an equation of the tangent line to the curve of the intersection of the surface z equals f of xy, which is given by the circular paraboloid 16 minus x squared minus y squared, A, with the plane y is equal to 2 at the point 1 to 11, and with the plane x is equal to 1 at the point 1 to 11. So I want you to do that. So what do we do? First of all, let us answer A. We put actually in a place of y 2, and then this will give us actually 12 minus x squared, because 16 minus a. Then now this becomes actually a function of a single variable. As you see now, dz dx equals negative 2x. And then now from here dz dx at x is equal to, the x value is 1. That means 2 times 1 is equal to 2. This is m. All right. Then now, if we get that, then now what is the equation an equation of the tangent line to the parabola. Parabola. That means the parabola is precondition y is equal to 2. Is that z minus the z value is actually 11, point slope form, m is 2, and x minus the x value is 1. And that is really what we get. And remember, y is equal to 2. Don't forget that. It is. So this will give me z equals 2x minus 2 plus 11. That is what we have. And then we'll do the same thing for the value b, the intersection of x is equal to 1 and z is equal to 16 minus x squared minus y squared is z equals 16 minus 1 squared minus y squared, and that is actually 15 minus y squared. That is what I have, and precondition that x is equal to 1. And then I would, is it clear what the argument that I'm making, guys? Yes? Now look, this is a function of single variable. That means the rate of change of z with respect to y, because it is a function of y. And that is negative 2y. And now this is a function of y. Then from here, actually, what is dz dy at the point the y value is actually 2. This is m. Then we know that y minus or z minus z sub 0 equals m into y minus y sub 0, point slope form of equation of a line. So z minus 11 equals negative 4. And by the way, here precondition x is equal to 1. Y minus the y value is 2. And this is z equals negative 4y plus 8 plus 11. Z is equal to negative 4y plus 19. And that's it. So I'm not going to really spend the time drawing, but I have the picture here. Let me show you what it looks like. If you really find the graph, look at the point here, by making y is equal to 2 constant, this red line is the equation of the tangent line. And similarly, by making the x value constant, x is equal to 1, parallel to the y-axis, and the curve is created this blue curve because the plane x is equal to 1 and the parabola are curving, the circular paraboloid will create this parabola which is open downward, and the tangent line is a red line. That is what it means. So do you guys get the geometrical interpretation? Does it make sense?
Yes.
And now let us see how the effect, the rate of change of one function over the other has been influenced. In other words, just simple. It can be money, it can be geometrical shape, it can be density of an object, and so on and so forth. And let us see what is really happening here. For example, the area A of a triangle with sides A and B and an included angle theta is given by, as you know, the area of a triangle with the included angle theta being 1/2 AB times sine of theta. In other words, this length is B, this length is A, and the included angle is theta. So this area, the shaded region A, is defined by this. Now, the question is how this area is going to be influenced by making a change in A, B, or theta for that matter. So I want to find the rate of change of the area with respect to A when B and theta are fixed. And secondly, find the rate of change of A with respect to B with this rate of change when this theta and A are fixed. And finally, find the rate of change of the area with respect to theta by holding A and B the sides fixed. And I want to evaluate all the three rate of change when A is 20, B is 30, and theta is 5/6. And I want to interpret the result that you found in D. Go ahead. And this one, because we ran out of time, I want to take a snapshot, take a picture of the question, and do it at home. Tomorrow we'll start from this section. And then to finish 14.2, I have only one thing beside this example to show you. That means, how about implicitly defined function, a function of 2 or 3 variables? And then how can we find that rate of change? I will show you, and then we'll go to section 4.3. I will post the homework today. I will release them right after I finish my class and start working on your homework. Please, before you do that, please answer all this. I know you can find the rate of change with respect to A, B, and theta, and I know you can evaluate also those rate of change at the given value, but I am interested in your observation of the interpretation of these rate of change. Thank you. I hope this will help you to remember what you learned in Calculus 3, and then we'll move on. See you tomorrow. Thank you, guys.
Thank you.
Bye-bye. It's becoming more interesting, guys, from now onwards. So please attend the class.